Hey y'all, this is Mr. Alexander, and I am recording this video for Pre-AP Algebra 2 students at Stony Point High School, and today I want to show you how to graph absolute value inequalities. So this is building off what we did last time. We're going to graph the inequality just the same way we did before, but now we're also going to shade the solution set. So let's start with here. What I like to do is I like to draw out in words the transformation. So that looks like right there, that's a vertical shift, sorry, a vertical stretch. And it looks like it's vertical stretch by 2. That minus 3 tells me that I'm going to shift from the origin 3 units right. And that plus 2 means I'm going to go up 2. So you might remember that the absolute value parent function starts at the origin. So we're always referencing the origin when we begin. So from the origin, I'm going to go right 1, 2, 3, and up 1, 2. I'm going to put a little dot right there. Now there's this matter of the vertical stretch. We need to go up 1, 2, and in either direction, I need to go over 1. And then from each of those dots I just drew, we're going to go up 2 over 1, up 2 over 1. And what we're trying to do here is graph this nice V shape. So up 2 over 1, up 2 over 1. Up 2 over 1, up 2 over 1. Okay, so I've got all my dots in place, but now I need to graph it. And the question is, am I going to do a solid line or a dotted line? We'll check it out. We've got greater than and greater than or equal to. Which one's dotted, which one's solid? Greater than is dotted. Greater than or equal to is a solid line. The difference being this equal sign. If you got that little bar underneath, that's going to be a solid line. So I'm going to go ahead and draw in a solid line. And we're not done graphing an inequality until we've filled in the solution set. We've shaded the solution set. So y is greater than. Greater than means above. So I'm going to shade the region above that line I just filled in. That's it, really. That's all we're doing today. It gets a little bit more complicated. We add a couple of little nuances in there, but we'll get into that. Let's go straight into number 2 here. So we've got y is greater than 3 absolute value of x plus 1 plus 3. So I see 3 transformations here. The first one is that 3. What that 3 tells me is another vertical stretch by a factor of 3. That plus 1 tells me that we're going to the left 1. And that plus 3 tells me we're going up by 3. So you start at the origin, go left 1, and up 1, 2, 3. That's our new vertex. And that vertical stretch now, that means that from the vertex we're going to go up 1, 2, 3, and over 1 in either direction. 1, 2, 3, over 1. And do it again from each of those new points. Up 1, 2, 3, over 1. Up 1, 2, 3, over 1. So I've got enough points on here to fill in the line. But is it going to be a solid or dotted line? And for that, you need to look at this. It says y is greater than. It doesn't say y is greater than or equal to. So this is a dotted line. Let's put the word dotted right there because it's not real clear on the graph. It's a dotted line. The last step is to shade. So now we're going to want to shade above because greater than is above. Okay. This one's dotted too. So, over here on the notes, we've got this thing where it says steps. The first step, let's get the y by itself. Isolate the y variable. Second step, identify the transformations. That's what we were doing here. This 1, 2, 3 business. That's identifying transformations. And after you've identified the transformation, you should plot some points. But you don't want to fill in the points yet, because then you need to decide, is it dotted or solid? And then after that, you're going to look at the inequality, that guy, and then shade the solution set. That's it. Those are the 5 steps. So let's do number 3 here. So now we've got 2 equations. So we're graphing a system of linear inequalities. And to do that, I always like to do it in pencil, so I just grab myself a pencil. Before we get started, I need to make sure that the y is by itself in both these equations. It's not in either of them. So what I'm going to do is I'm going to subtract 5 in this first equation, so minus 5, minus 5. So that first equation is y is less than or equal to absolute value of x minus 1 minus 5. Make sure you put that on the outside of the absolute value. Just because we're subtracting it doesn't mean you can subtract it to the inside of the absolute value. That's not okay. You can't do that. Put it on the outside. Now I've got this negative 3y less than or equal to 1 absolute value of x plus 4 minus 6. So I'm going to want to divide both sides by negative 3. And you want to divide that to every single term inside there. So y, I divided by a negative, so I need to flip the sign here, is now greater than or equal to, and I've got this weird fraction thing going on here. It's actually easier than it looks. You're going to want to do this 1 divided by negative 3. Since this is multiplication in here, we can just do it to this first term here, and then we can move that fraction out front. So this is going to become negative 1 over 3 absolute value of x plus 4. And then I've got this negative 6 divided by negative 3. Well, negative and negative makes positive. And 6 divided by 3 is just 2. Okay, so now I'm looking at both these equations. I'm seeing 2 transformations here, and I'm seeing 4 transformations here. So let's identify all of them. 1, 2. Okay, that minus 1 means go right 1, and that minus 5 means go down 5. Okay, well, I'm just going to do that real quick. So right 1, down 1, 2, 3, 4, 5. So I'm going to go ahead and plot this thing really quick. You need to ask yourself, is this a solid or dotted line? Well, see the or equal to right there? That's a solid line. So I'm just putting some dots here, make sure that my line's nice and straight. And I recommend you use a straight edge. That's what I'm going to do. I'm going to use a straight edge here to make sure this line comes out nice and straight. And it's a solid line, so that's all right. So I've graphed the first equation, but I need to shade it. So it says y is less than or equal to. That means shade below. I'm going to do that in pencil really lightly, because remember, with systems of inequalities, we're only interested in the region that's shaded twice. So I just shaded this really lightly with my pencil, because that's not the answer, not yet. Because now we need to graph this y is greater than or equal to negative 1/3 x plus 4, absolute value of x plus 4 plus 2. So there's 4 transformations, 1, 2, 3, 4. The first one's this negative. That makes it a reflection. The second one's this 1/3. That's a vertical compression by a factor of 1/3. That plus 4 means go left 4. And that plus 2 means go up 2. So I'm going to start at the origin. I'm going to go left 1, 2, 3, 4. And then I'm going to go up 1, 2. And I'm going to put my dot. That's my vertex. Now I know this thing's upside down because it's a reflection. This vertical compression tells me which way to go. It says go down 1 over 1, 2, 3. In either direction. Down 1 over 1, 2, 3. And then go down over 1, 2, 3. Down over 1, 2, 3. Down 1, 2, 3. Down 1, 2, 3. All right, is this a solid or a dotted line? That sure looks solid to me. So use a straight edge, make sure this comes out nice. And so, straight edge. Connect the points. Do it over here too with a solid line. Make this one nice and bold so I can tell the difference between the two lines. And now, a little bit bolder up here. Now it's y is greater than. So I need to shade above. Now the solution to a system of linear inequalities is the region, or in this case regions, that are shaded twice. So I'm going to make those ones nice and dark with my pen. It's this one and this one. Those are the places that are shaded twice. And if you like, if you do it in pencil, you can just erase off this other stuff you shaded so that you don't get confused. So it's these two regions that are the solution set. Okay, that should be it. We've now graphed inequalities. In this case, absolute value inequalities. I think I was saying linear inequalities before. These are absolute value inequalities. And we've done systems of absolute value inequalities. So that's it. Thank you for watching, and good luck.